Hi, this is Marwan, and today we will be discussing how to divide radical expressions. We had two previous videos about radical expressions. One of them was about simplifying and the other was about multiplying radical expressions. Now in our video today, we are going to be discussing how to divide radical expressions and how to rationalize the denominator in case we have a radical expression in the denominator. Now the first example, before we go through it, we're going to look at the rule we have. If the nth root of a and the nth root of b are real numbers, and b does not equal 0, then the nth root of a over the nth root of b is equal to the nth root of a over b. Now what does that mean? As we can see here, we have b in the denominator. And this is why it should never be equal to 0, because if the denominator is equal to 0, then the whole expression will be undefined. Since both of them have the same nth root, so this is nth root and this is nth root, like both of them are cubic roots, both of them are fourth roots, then I can actually divide a by b. So let's look at our first example here. We have the square root of 500 divided by the square root of 50. Well, if I can divide 500 by 50, which is the square root of 100, I can easily find the square root of 100 to be 10. Now there is another way where you actually rationalize the denominator, and we're going to discuss that in a minute, but my advice to you is if you can simplify first, just simplify. You might not need to rationalize denominators in the future. Now let's look at our next example here. Now I can actually divide, let's find out. Can I divide square root 56 by 7? Yes, then under the square root, 56 divided by 7 is 8. And x to the power of 5 divided by x is x to the power of 4, and y to the power of 5 divided by y is y to the power of 4. How do you know? You just subtract the exponents. 5 minus 1 is 4. 5 minus 1 is 4. Now both of these are perfect squares, but I'm not sure about the 8. Well, the 8 is, as we know, 2 to the power of 3. It's not a perfect square. So what can I do about that? I'm gonna break it into a perfect square, which is 2 squared multiplied by 2 multiplied by x to the power of 4, y to the power of 4. Now I'm going to take them outside. Every perfect square, I can take it outside of the radical. Remember that we need to use absolute value. 2 squared, the square root of 2 squared is 2. So I've got rid of this. Square root of x to the power of 4 is x squared. I've got rid of this as well. And square root of y to the power of 4 is y squared. I still have under the radical the 2. Now, should I use absolute value? Well, I should use absolute value. Then I check. Now the 2 is positive anyway, so I can take it out. X squared has an even power, so I can take it out. Y squared has an even power, I can take that out as well, and this is your answer. So you did use the absolute value, but because both exponents were even, then you can take it out because it's going to be positive anyway. Now let's look at our other question here. This is the cubic root. Can I simplify? 250 divided by 2 is 125. And x to the power of 7 divided by x squared, well, 7 minus 2 is 5, so this is x to the power of 5. Then y cubed divided by y, this is y squared, equals. Let's first find the prime factors of 125. Well, 125 is equal to 5 times 25. 5 is prime. 25 is 5 times 5. Both are prime, so this is 5 cubed, which is a perfect cube. Then I have x to the power of 5 is not a perfect cube, but I can break it into a perfect cube plus the rest. And y squared, well, there's nothing I can do about that. So whatever was a perfect cube, I can remove from the cubic root. So I have 5, I'm done with that. Cubic root of x to the power of 3, or x cubed, is x. I'm done with that. These two, there is nothing I can do about them. So I have cubic root of x squared, y squared. So this seems easy and nice because we could actually simplify all questions. Let's see what happens when we can't simplify. When you can't simplify the questions, we do what we call rationalize. Now this question here is asking you to rationalize the denominator of each expression. So I have x and 2, a variable and a number. There is nothing I can do about it. So what we do is whenever you see this, although there is nothing you can do about it, you cannot leave the denominator as a radical. It's not possible. What we need to do is we need to get rid of this radical. How? I need to find the perfect square for 2. 2 does not have a perfect square. If it was 2 squared, then I can take it out of the radical. So this is actually what I'm going to do. I'm going to multiply both the numerator and the denominator by the value that can make this square. So if 2 was squared, it would have been fine. I have only 1 2, then I need another 2. Same way I do with the denominator, I'm going to do with the numerator. Then I'm going to multiply. Square root of 2 multiplied by square root of 2, well, 2 times 2 is 2 squared. And the square root of 2 multiplied by square root of x, this is 2x. When I simplify, square root of 2 squared is 2, and this is radical 2x, and this is the answer. What did I do? Because I couldn't simplify, I have to rationalize. The denominator of any expression cannot be a radical. It needs to be rationalized. Now let's look at our next question here. I have the square root of 5 divided by square root of 8x. First of all, change it into prime factors. Why do I do prime factorization? So I know if I can take anything out of the square root, so which will help me simplifying before I rationalize. Well, this is going to be 2 cubed multiplied by x. Well, 2 cubed is 2 squared times 2. Why am I doing this? To get perfect squares, so I can actually simplify. So I have 2 square root of 2x in the denominator and radical 5 in the numerator. I need to rationalize. I need the 2 to be squared and the x also to be squared. So I'm going to multiply both numerator and denominator by radical 2x. So I have radical 2x here and radical 2x here as well. After you multiply, what are you going to get? Well, this is going to be radical 10x when you multiply 2 by 5, and here I'm going to have 2, then square root of 2 squared and x squared. When I take them out of the radical, this is going to be square root of 10x the way it is, and this is going to be 2 multiplied by 2 multiplied by x. Remember, this is a square root, so I need to use a absolute value. Now, this is going to be square root of 10x, and as we agreed before, I can take the number out. 2 times 2 is 4, and I'm going to leave the absolute value inside, the variable inside the absolute value here. However, as we said, because it's to the power of 1, it's going to stay inside the absolute value, but I need to check the original expression. In the original expression, it was only x, so it did not have an even power, it had an odd power. There is no way this was negative. If it was negative, the whole expression would not be real. So now I can actually remove it from the absolute value. Let's look at another question. Well, in this question, check first, can you simplify before you attempt rationalizing, because it will take you less time. 15 divided by 3 is 5. Then I have a square root. 60 divided by 12 is 5. X to the power of 5 divided by x is x to the power of 4 equals 5 stays, the other 5 under the radical, there is nothing I can do about it, but x to the power of 4 is a perfect square. Divide 4 by 2, so I'm going to take an x square here, radical 5. Should I use an absolute value? Yes, because the index was even. However, I'm going to check how reasonable my answer is. I can take the 5 out anyway because it's a number. The x square, because it had an even power, I'm going to take it out. It means it's positive anyway. Then absolute value of 5. So again, although I needed to have an absolute value, like in the first question, I removed it. Here, because the power is even, or the exponent is even. Here, because it was radical x to start with, so there is no way it would have been negative. Now, one last question. I am going to again try my best to simplify first, but apparently not everything is going to be simplified. 12 and 10, Well, both of them are divisible by 2. So this is going to be 6. This is going to be 5. Then I'm going to find prime factors and see if I can do anything else. I have a and a cubed. Well, if I divide a by a cubed, then it's going to be 1 minus 3, which is negative 2. Then it's going to go only in the denominator, and I have nothing in the numerator. B cubed divided by b, subtract 3 minus 1, you'll get 2. This is b squared in the numerator. C squared divided by c is only c in the numerator. So this is my answer here. If I check, I will find that for the denominator, none of them is a perfect cube, and it cannot even be broken into a perfect cube. So I need to rationalize. What I need to do now is actually rationalizing. I'm going to rationalize by multiplying both numerator and denominator by whatever makes this a perfect cube. So I have here 5. I need another 5 squared to have 5 to the power of 3. I have here a squared. I need only an a to make this a to the power of 3. If I multiply the denominator by cubic root of 5 squared a, I'm going to multiply the numerator by the exact same expression. So 5 squared a. Now when you multiply, you are going to get the following. In the denominator, this is going to be the cubic root of 5 cubed, a cubed, so that will be easily taken rid of. In the numerator, it's going to be the cubic root of, then you're going to multiply. 5 squared is not a perfect cube, so you can't remove it anyway. And 6 is 2 times 3, and none of them is a perfect cube. If you multiply 6 by 5 squared, which is 25, your answer is going to be 150. Then I have an a, then a b squared, then a c. So all of that is in the numerator. Remember, when you write an algebraic expression, write the variables in alphabetical order. So this is 150, a, b squared, and c. The denominator is actually the cubic root of 5 cubed is 5, cubic root of a cubed is a. I'm not going to use an absolute value because I had an odd index. Now, I hope this has been helpful for you and it made you understand better, and thank you so much for watching.